In this video, we're going to take a look at the Banzhaf Power Index. Our hero of this story is off to the right here, this handsome fellow. So in 1965, John Banzhaf introduced his interpretation of power. What do we mean by someone wielding power? He thought a player's power should be measured by how often the player is critical. Remember critical players from a previous video. He thought that the more critical a player was, the more power they wielded. Remember, critical is if you leave a winning coalition, they can no longer win. So using the Banzhaf method, we can describe each player's share of the power in the form of a percentage. Okay, so the way that that's done is we take a look at, how all of the critical players, and then we assign somebody a percentage. Okay, and so the key is the total power distribution has a sum of 100%. So we're always looking at what percentage out of 100 of the power does any one player have. This method can be outlined in these 4 steps. So to calculate the Banzhaf Power Index, number one, you have to list out all the winning coalitions. We have some practice with that, but that can be tedious. We're only going to look at 3-player and 4-player systems because more than that is pretty tedious, and a lot of times you might need the aid of a computer to keep track of all the coalitions. The second thing you do is you figure out who is critical, right? Where are people critical? We've done that before. Number 3, you count up how many times everybody's critical. And number 4, you convert that count to a percentage of the power by using fractions and division. We'll use a calculator for that. Let's take a look at our first example doing these 4 steps out. All right, so the first thing we need to do is take a look at the winning coalitions. So in this problem, we have a quota of 7, and our weights are 5, 2, and 1. All right. So how many ways can we win? Well, there's no dictator. Nobody has enough to vote by themselves. There's no 1-player winning coalitions, but there are winning. There is a 2-player winning coalition. If you take player 1 and you take player 2 together, right? That's 5 plus 2. That's 7. That's enough. But no other 2 players would be enough. The only other winning coalition we have is the grand coalition. If you have players 1, 2, and 3 all together, 5 and 2 and 1 is 8. That's enough to win. So that's the first step. The next step is to kind of count or identify when somebody is critical. In the first coalition, both players are critical because if either one leaves, you won't have enough to win. So player 1 and player 2 are critical. In the grand coalition, however, player 3 is not critical. And they're not critical because if they leave, if their 1 vote leaves, players 1 and 2 still have enough. But players 2 and 1 must be in the coalition for it still to win. Otherwise, you don't have a total of 7 votes. Notice that if you add player 1 and player 3, that's only 6. That's not enough. So if player 2 is out, we don't have a win. So in this case, player 1 and player 2 are, again, still critical. So in the box to the right, we fill in the number of times that people were critical. Player 1 was critical twice. Player 2 was critical twice. And poor player 3 was never critical at all. All right. Then you take a look at converting those. That's the count. That's number 3 done. Number 4 is converting those to the percentage. So the way you do that is take a look at the total number of times that people were critical. 2 plus 2 plus 0 is 4. And then you give them a percentage by looking at the fraction. For player 1, they had 2 out of the 4. If you grab your calculator, you might know it in your head. 2 divided by 4 is 0.5. Move the decimal place twice or multiply by 100. You see that's 50% of the power. We have the same exact calculation for player number 2, having 50% of the power. For player number 3, 0 times out of 4, that of course being 0%. So what this means is, it's kind of interesting, is that even though the third player has a vote, 1 vote, they don't seem to have, any power. It's kind of weird. And the other thing that's strange about this is the first 2 players have a different number of votes, 5 and 2, but they seem to have the same amount of power. Now, you might have thought, and anybody might have thought, that if 5 votes is more powerful than 2, but by Banzhaf's measure, since they're never more critical than the other, they really don't have any more power, even though they have more votes. So it gives us a new perspective about what we mean by someone having power when we consider how many times they're critical. Let's take a look at a second example. I'll get you involved a little bit. In this one, the quota is 6 and the weights are 5, 3, 1. Again, we have no dictator, so there's no 1-player winning coalitions, but we do have something in 2-player. All right, so let's see. If you get players 1 and 2 together, that's enough. 5 plus 3 is 8. But also notice that if you get player 1 and player 3 together, that's 5 plus 1 equals 6. You also have enough. So there's 2 different ways to have a winning coalition. However, players 2 and 3 together will not be winning. The other winning coalitions would be 3-player, all right? So in this case, there's 1 because there's only 3 players. Obviously, if you have all 3 players together, that's enough to pass the vote. 5 and 3 and 1 is 9. That's plenty. So when we figure out who is critical here, in the 2-player system, since there's no dictator, they're both critical because you have to have both. You have to have player 1, you have to have player 2. Here you have to have player 1, and you have to have player 3 to be able to make up a 6. In the last line, though, if you take out player 3, players 1 and 2 have enough. And also, if you take out player 2, players 1 and 3 have enough. Like if player 2 is gone, right, you still have 5 plus 1. The only player that is critical is player 1, all right, because players 2 and 3 cannot pass a vote by themselves. Now we have the count. If you look at how many times I've circled things, I've circled player 1 3 times, player 2 1 time, and player 3 1 time. This gives us a different number. We always have to consider the total may change, right? In this case, it's 5. Player 1 has 3 out of the 5. Player 2 has 1 out of the 5. And player 3 has 1 out of the 5. You go ahead and do the division to figure out what the percentages are for each. Go ahead and pause while you consider what that will be. Okay, so you can see that just changing the weight slightly or the quota slightly can really change things. Let's take a look at one 4-player example here together. In this case, the quota is 10. The weights are 6, 5, 4, and 2. No dictators. We do have a 2-player winning coalition, though, right? Sure, we have that. The first 2 players have weights of 6 and 5, so that's enough. 6 plus 5 is 11. And also, if you add up player 1 and player 3, it's going to be enough because 6 plus 4 is 10 and the quota is met. There's no other way to meet the quota. Right, if you look at 3-player winning coalitions, it gets a little tricky, but player 1, player 2 is already winning, so you could add in player 3, or you could do player 1, player 2, and add in player 4. All right. Also, the second, the one from above, player 1 and player 3 was a winning coalition. So we could do player 1, player 3, and add in player 4. The last thing to consider is what if player 1 is absent? And it turns out we have enough. 5 and 4 and 2 is 11. So that also is a winning coalition. And that would be players 2 and 3 and 4. You'll notice that I'm listing the players in ascending order, right? I'm always putting the numbers in order. This helps you keep track of the winning coalitions and make sure you don't repeat any. Like, for example, if you said, player 4, 3, and 1 is a winning coalition, you already have that listed here. So you don't want to list things accidentally twice. And then, of course, there's also the grand coalition, right? All 4 players together is a coalition that wins. So that's quite a bit more work. Our job now is to figure out who's critical. There's no dictators. So in the first 2, right, everybody's critical. Nobody can leave, right? In the 3-player, we have to be a little more careful. In the 3-player, can anybody leave? Well, if player 3 leaves, we're good. And if player 2 leaves, we still have 10. But if player 1 leaves, we only have 9. So it turns out only player 1 is critical there. And similarly, in the second one, player 1, 2, and 4, 4 can leave. In this case, right, 4 can leave. Well, it's not similar. I should say it's slightly different. Player 4 has a weight of 2, and players 1 and 2 wouldn't be enough. But if player 2 leaves, it's a little different. That would be a 5. If player 2 leaves, right, then all we have is player 1 and player 4. 6 plus 2 is 8. That's not enough. That means player 2 must stay. They're critical. And of course, if they're critical, player 1 is critical. All right, in the third one, players 1, 3, and 4. That's what the weights are. 6, 4, and 2. So player 4 can leave because player 1 and 3 would be enough, but player 3 cannot leave because then they can't handle it. So here we have player 1 and player 3 are critical. In the last one, no 2 players by themselves can make this up. So it turns out in the last one, all 3 of the players are considered to be critical. All right. In the grand coalition, this one's kind of interesting here. And this time, any one player can leave and it won't matter. I'll just give you an example by saying, what if player 1 left? If player 1 left, we'd still have players 2, 3, 4, and that would be enough to win. That means that player 1's not critical. And if they're not critical, then nobody's critical. So we don't have any new revelation there. All right, so if we add up all the times player 1 is critical, let's see. We got 1, 2, 3, 4, 5, quite a bit. All right, so that's 5 times. All right, player 2, let's see. We got 1, 2, 3 times right there. Player 3, 1, 2, 3. And player 4, just 1 time right there. Now, what I like to do sometimes is go back and count all of the things I've circled to ensure that I actually got it right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And then just make sure that that matches my total over here, right? If I add 5 and 3 and 3 and 1, it needs to be 12. You can easily miscount, and you don't want to do that. So this time we're going out of 12. All right. So our Banzhaf power index would be 5 out of 12, 3 out of 12, 3 out of 12, and 1 out of 12. All right. And these, in this particular example, you're going to do a little bit of rounding. All right. So the first one, if we do 5 divided by 12, we get this repeating decimal forever. I'm just going to go to 2 decimal places. So it's about approximately rounds off to 0.42. I actually get 41666666. I'm rounding off to 42. I'm going to say they have 42% of the power. All right. 3 out of 12 is a nice number. It's exactly 0.25, 25%. This one is the same thing. It's 25%. And the last one, you need to do 1 divided by 12. You're going to get an ugly decimal, 0.083333 forever. It's about 0.08 rounded off. So we'll say they have 8% of the power. And that gives you an idea of how to calculate the Banzhaf power index. Okay. In this last example, I'm going to show you below. I'm going to have you do a lot of the work. All right. This last example here, the Banzhaf power index needs to be calculated. This weighted voting system, the quota is 5, and the weights are 3, 2, 1, and 1. Now, a few questions about that.